everybody. Today we're going to do some more ML coding. So we're here at deepml.com and we're going to start with the first problem, matrix vector dot product. So this problem, what we need to do, oops, I'll reset this over here so we didn't see what happened. What we're going to do is we're going to write a Python function that computes the dot product between a matrix and a vector. The function should return a list result with the resulting vector if the operation is valid. We'll talk about what that means. Or -1 if the matrix dimensions don't match. A matrix can be dotted with a vector. These are also, a matrix would be a list of lists over here, and the vector would be a list, only if the number of columns is equal to the length of the vector. So we'll see how to check that. For example, if an n by m matrix requires an m length vector. Here we have kind of an explanation of what that is. So what we want to do, we got a list of lists over here and the matrix B. So there's actually two ways to do this. I'll show you a more explicit Python way, and I'll show you how to solve this also using numpy, which makes everything much, much easier. So let's first solve this using the more explicit way, because I think that's we can learn a little more from that. So we'll have our output list. Now we're going to start to populate it with resulting dot products. So we're going to iterate through the matrix A. And now what we're going to do, we're going to try to keep track of the sum. So this would be the resulting output. And we're going to set it to 0, because you're going to see we're going to start adding elements to it. And now I'm going to do, if the shape of this is not equal to the length of the vector b, we can't multiply them, because we will just have a mismatch of the shape. This is exactly what they want. So if any of these rows is not equal to the length of the b, they want us to return -1, as you can see over here. Return -1. Otherwise, let's start doing this multiplication. So I'm going to use a cool thing that I like called zip in Python. So what we want to do is we'll take the matrix element and the row element, and we'll zip, which means we're iterating across both the row and the vector b at the same time, and we're making sure that these two are matched. So it will take the corresponding row element and the vector element. And now what we want to do is multiply them and add them to our sum. So this is how we do matrix multiplication. Take each element from the row vector of the matrix, and this is, my bad, I had a typo here. It's from the row element and from the vector element. Had a mistake over there. Now we fixed it. And what we're going to do is we add them to the sum, and then we add this output of the sum to our output vector, and then we just return it. So if we recap, we started with an empty list. Now we go over each row, then we start with the sum. If there's a shape mismatch, we return -1 as we needed to. We iterate through elements from both the row and our vector b. And then this is how we do the dot product. We sum up all the multiplications, and then we add this to our output array, and that's that. So let's see if this runs properly. And it takes a little bit of time, and yes, it does. And this also includes a test case where the shapes don't match, for example, this one. Now, let's see how we can do this in Python, in numpy, which is a little more efficient, because here we're doing a double for loop in Python, which is very slow. So what we're going to do is we're going to import numpy as np, and what we're going to do is we're going to try to convert both of these into a numpy array. So we'll convert A into a numpy array, and we'll convert B into a numpy array. Now, if we have a very special situation where it's a list that one of them is of a different size, this line will fail. In this case, we would need to handle this with a certain handling of exceptions, but it's not going to happen over here. But just so you know, this might fail if there's a list of lists that isn't the same shape. What they designed this for is to make sure that the matrix is valid, but there is a possibility that the shapes don't match. So what we're going to do is check the shapes. So we want the shape of the number of columns, which is multiplied by b. So this is the shape of each row and the shape of b, and this is what we want to be compatible. If it's not, we need to return -1. Otherwise, what we do is we need to just return A times B. When you do this with the @ sign, this is how you do matrix multiplication with numpy. And we actually need to convert this to list, so we're going to return it as a list, because you see we need to return it as a list. This is a little more compact, and it's more explicit also what this is checking. And usually this is going to be way, way faster than a double for loop in Python. So let's see if this runs. Why didn't this work? No tests available. Let's see if this works now. Yes, it does. Very cool, including the test that it have shape incompatibility. So usually this is what you would use to multiply a matrix and a vector, or a matrix and a matrix, which we'll see later. But I hope you learned something, and come back to watch more videos.